Welcome to the course on Big Data with Hadoop. As part of this session, we will be discussing on various design patterns which we will be using generally in MapReduce. Basically, we begin with what is a design pattern, what is MapReduce, then we will move on with various patterns of design in MapReduce, where we will be focusing on summarization patterns, filtering patterns, data organization, join and input and output patterns, where in summarization pattern we will be covering numerical summarization patterns. In filtering we will be focusing on top 10, distinct and various examples, whereas in join patterns we will be covering reduced side join. So, these are few examples which we will be covering in various patterns. To begin with, today I will be mostly focusing on what is design pattern and MapReduce. So, first we will be discussing on what is design patterns. Basically, all the software developers who are very much expertise, they find out certain patterns which are nothing but certain solutions, common solution when defined solutions towards various problems which they are going to come across or encounter again and again while developing a software. So, in simple terms we can say design patterns describes or represents a well known or battle tested solutions towards the problem which software developers face on a day to day basis. And coming to these design patterns, it is not code, it is a conceptual entity. In short, we can say design patterns as certain algorithms, where in algorithm we will have a step by step process to attend to a solution of a particular problem. Likewise, design patterns are conceptually built, where you can implement this using any programming language. In short, design patterns are such as it is said to be a blueprint. It is a blueprint towards the problem. It is a blueprint to solve a certain problem. When I am saying it is a blueprint, and you cannot directly use it in your code, just like what we do with functions or libraries. Basically, inbuilt functions or libraries we import into our code, that we cannot make it out possible using design patterns, as it is a conceptual entity which shows a way to solve a particular problem. And as I said, it is not a piece of code, but generally it is a concept to solve a particular pattern. Whereas coming to this design patterns, you can implement the solution using any programming language which you are comfortable for. Coming to these design patterns, if you are going with any of the patterns such as summarization or else filtering, join or input output patterns or data organization pattern, any of the pattern will have all these four. What are those four? First, what was the intent of the pattern? Second, what is the motivation? Third, how it is structured. Fourth, the code example. Coming to the intent of a pattern, it briefly describes about the solution for a particular problem, whereas motivation, it explains in detail for what sort of problems we can use which particular pattern. Coming to the structure, it depicts in a diagrammatical way how to obtain a solution to a particular problem in a pictographical manner. Based on the structure, we will be building our code using any popular programming language. So these are the four entities which constitutes any pattern. So to begin with, what is MapReduce? MapReduce is a programming framework or programmatical model to process huge amount of data which was stored across hundreds of computers. Basically in MapReduce, we do have two tasks. One is map task, the other one is reduce task. Internally, each and every task, map task is partitioned into 4 phases, whereas reducer is partitioned into 4 phases. Record reader, mapper, combiner, partitioner. Whereas combiners and partitioners are optional phases. If you require, then you can implement. If not, you can skip it up. And whereas shuffle and sort, it is treated as a single reducer and output format. Let us see one by one. What is the role of record reader? Basically, when you are going to store a particular document into HDFS, this HDFS will split the file into blocks which are referred as input splits. Now these input splits were being taken as an input by the record reader and transforms each line of input split into records. And these records are going to be inputted to the mapper, where mapper will perform its own logic on the key value pairs which are being produced by the record reader, and it generates an intermediate key value pair. And this key value pair, if you are using combiner, then those are going to be the input for the combiner. Combiners are also said to be the local reducers. As you can see, this is an intermediate key value pair which was being generated. If it will be stored onto the local disk of that particular machine. And locally, and what is the need of this combiner is to reduce the usage of network bandwidth. If you are going to see word count example, where we are going to count number of times a particular word has been repeated in a particular document. So if hello is a term which has been repeated for 3 times, if you are not using the combiner function, then these hello comma 1 will be sent over the network for 3 times. Instead of that, if you are going to use combiner function, then this hello comma 1 will be sent only once. It means that it will reduce or it will aggregate the output into 1, the similar output, and it will transfer it over the network. Coming to the next phase, that is partitioner. Partitioners are basically used to take the input of mapper, or else if you are using combiner, then output of combiner will be the input for your partitioner. It will split the data into shards, and one shard is being applied for one reducer. So number of reducers depends upon number of shards created by your partitioner. The output of this partitioner will be the input for your shuffle and sort. In shuffling and sorting, what happens? It will shuffle the data from one machine to another machine, according to the need. Some data will be moved from one machine to another, some data will be moved from first to another. So this shuffling will be done by the shuffle phase, which will be the hidden phase, and automatically executed by the Hadoop framework. And once the shuffling has been done, it will sort the data based on chronological order, just like dictionary chronological order. The sorting and shuffling, these are the phases which are going to be internally managed by your Hadoop framework. Once shuffle and sort has been done, then the output of shuffle and sort will be produced to reducer. In reducer, what we are going to get is aggregated values. The basic funda, what logic we are going to apply in reducer is the aggregation on the keys. and this will be producing an output file which is said to be the output format, and it will be stored onto your HDFS using the record writer. So, this is these are the phases in map reduce. So, here we comes to the end of the session. Thank you.